Yo, yo, word up, Canu in the house! Okay, this is chapter 5B. Periodic trends. So there are, in other words, a trend is a predictable change in a certain direction. So we can look at the Ford Mustang from 1964 to about 2014 to give you an idea that through the decades there have been changes. 64, the 70s, the 80s, the 90s, the 2000s, and the 2010s. So you can see that over time that there has been changes there in one of God's own cars. The Chevy people are going to kill me, but anyways. We have to look at atomic radius, the size of the atom itself. We measure it using something called X-ray diffraction, and it is determined by the electron cloud. Wait, electron cloud, what are you talking about? Remember back in chapter 4 we talked about the idea of Heisenberg's uncertainty principle, where we don't know where the electron's going to be or how much energy it's got, but we know that there's going to be a region, an area, a volume where the electron would hang out, and this would be it. So we can look at the average distance of the electron from the proton here, and we can sit there and look at the distance. This is the electron cloud, where the electron can be hanging out in any part of this electron cloud. Remember, it's a region. An atom is mostly empty space. So that's when we're talking about the atomic radius. We're looking at the distance of the electron cloud from the proton, which basically it's in the middle of the atom. Okay? Now, so the general idea is that the atomic radius, that if we look at the periodic chart here, if we go from right to the left, it actually gets a little bit bigger. A little bit. As you go down from top to bottom, it also gets bigger. Now, there's some key things here to understand about the trend. Okay, so we can say from the trend that going from right to left, going across, okay, it gets bigger. If it goes from top to the bottom, it also gets bigger, which I put in this picture from Christmas Story. You remember he's the younger brother of our hero, I think. And cold winter day, Mom put him in layer after layer after layer of clothes that he could barely move. Well, you know what? When you go down the column, when you go row after row, it's another layer of electrons that are added, much like another layer of clothing that Mom clothed her beloved son so he doesn't freeze to death and catch pneumonia and die! All right, let's move on here. So, we also have to look at ionic radius. Wait, ionic? Where are you throwing this one, Canu? Chill. Ion. Remember, an ion is an atom that has a positive or a negative charge. Well, how does an atom get a positive or negative charge? Well, you either pick up an electron or you drop an electron. That's it. So what goes on? Well, cations are smaller than their parent atoms. If an ion drops an electron, it gets a little bit smaller and it has a positive charge. Well, how come? Well, that's because the electron took off for whatever reason, and now the thing shrinks a little bit because of that. Anions are the opposite. If they pick up an electron, they end up getting bigger as a result. So that's when you look at cations versus anions. So that's when you get into ion or ionic radius here. So if I were to just go and look at here, let's just go ahead and we'll just take good old chlorine right here. Here's chlorine. Now, this is chlorine with a 0 charge. Now, chlorine has 7 electrons in its outermost layer. The magic number that chlorine wants is 8. So it's going to pick up that 1 electron. The moment it picks up that 1 electron, it becomes huge. Okay? It becomes huge, becomes bigger because of that 1 electron that it picked up. That's the key thing that you have to be aware. So atoms pick up electrons, they get bigger. If they lose electrons, they get smaller. That's what's going on. Now there is also something known as ionization energy. The energy needed to take an electron from an atom. Now some atoms, it's not really a big deal. You don't have to put a lot of energy for them to give up an electron. On the other hand, some of them, it's, I'll fight you. Okay? So for as an example, lithium plus energy, we get lithium with a positive charge and an electron. This is what we call the first ionization energy. Now we can sit there and rip out other electrons from the atoms, but usually it tends to take more energy. So generally speaking, it increases if you go from left to right inside a row, a period, and it decreases from top to bottom within a group. Noble gases, it takes a lot of energy to do it. So what does that mean? What's happening? Well, you know what? It's going to increase as you go from the left to the right. Well, how come? Why is that? Well, you've got more electrons here, and what they want to do, they want to hang on to, the atoms want to hang on to the electrons they have because they have more protons here, right? And they want to hang on to their electrons, so it's like, mine, 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 man, you can't have it. That means you have to put more energy into getting it, okay? On the other side of the coin here, as you're going up, it increases the ionization energy. It takes more energy to rip out an electron. Well, how come? Well, remember, here the atoms are bigger, right? They're bigger because of their size, their level. Okay, when you go up a group or a family, what happens is you're going up row by row. It's getting smaller. If it's getting smaller, then that means there's fewer electrons, and they're also holding on to it, the nucleus, and therefore you need to put effort into pulling them out. It still can be done. We can do second ionization, third ionization, fourth ionization. We can do that, but that's outside the scope of our course here. Then we have something called electron affinity. We looked at atomic radius. We looked at ionization energy. Now we've got to look at electron affinity. How much energy does it take to add an electron to a neutral atom to make it negative? So in other words, it's the opposite of ionization, electron affinity. In ionization, we were ripping the electron out. In electron affinity, how much energy do we need to make an atom take the electron to go from neutral to negative? So it's the opposite. If you're going from left to right, it actually increases along a period. It is the absolute opposite, okay? You do need to get more, put in more energy to make them take it here. Now, electronegativity, this is a little bit different. This is defined as the measure of the attraction between the nucleus and the valence electrons. Okay? And usually it's determined for atoms bonded in molecules. And this is kind of an important thing. The higher the electronegativity value, that means there's more attraction between the nucleus and those outermost electrons, those valence electrons. The lower the value, I'm not really that interested in it. But I still have some interest. So when we go down here, up here, we tend to have more attraction between the nucleus and the valence electrons. Here, when you look at lithium and sodium and potassium and rubidium, they're like, I'm not interested. So it's a very low electronegativity. Okay? And that's actually going to make a difference in how those atoms hook up with each other. And with that, we are done here with Chapter 5, Part B.